What's up there, y'all? This is Mr. Longo here, about to go over how to work with some radicals. Now, for those of you that do not remember what a radical is a fancy name for a square root. But radicals can be cube roots, fourth roots, fifth roots. But today we are focusing on square roots. So, not all square roots are going to be nice, beautiful numbers. So, the square root of 9, you should all know, is 3. And the square root of a negative 25. If you were to think about that for a minute, you should come up with not possible because you can't take the square root of a negative number. And you can think about why. If we take 5 and we square it, we get a positive 25. And if we take a negative 5 and square that, we still get a positive 25 because a negative 5 times a negative 5 is still a positive 25. So you cannot take the square root of negatives. But if you take the square root of 8, you end up with 2.82847, blah, 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 and it's a big, nasty decimal. So what we're going to work with is simplifying radicals so we have an exact answer. So to simplify radicals, sometimes it's going to require a few steps, but you are basically going to break it down into, easier terms to work with. So the square root of 3 we know is a square root of 3. It cannot be simplified. But using the last example we just talked about, the square root of 8, there are a few ways to do this. Now, if you think about dividing everything by the biggest perfect square, that will work out easily for square roots. So we could think about 8 being 4 times 2. So the square root of 4 times the square root of 2 would be, square root of 4 is 2, square root of 2 we can't do. So we still have 2 root 2, which is going to be our final answer. The reason I do not like working with that method is because when you get to algebra 2 trig and beyond, if you have to take a perfect fourth root example, the smallest fourth power is 16, and I'm guessing you're not going to be able to very easily divide a whole bunch of numbers by 16 or above. So what I like to do is use the factor tree method. And the reason why is because it'll work for square roots, for third roots, for fourth roots, and stuff like that. So what you do is you break down 8, and you divide by 2, and you get 4. And then you break down 4, you divide by 2, and you're left with 2. And once you get down to the bottom, you are done with your factor tree. Once it cannot be simplified anymore without dividing by 1, of course. So then what you have to do is think about what you're working with. Now, everything that we do today is going to be a square root, so you need groups of 2 to be a perfect square. And whatever is left over gets boxed, so you need groups of 2. So if you circle a pair of 2s, that means they can come outside. And if you have anything boxed, that means it stays in the radical. And you get the exact same answer, and that's because 2 times 2 is 4, so that would be like, again, saying that the square root of 2 times 2 times 2, that can come outside because it is a perfect square root of 4, leaving you with the 2 on the inside. So again, there's multiple ways to do these. Now, what you have left in front of you is just more examples of that. So what I want you to do for the next one, 216, is I want you to break it down using the factor tree. Okay, and again, I like to start with 2s, but you do not have to. But you'll see the way I do, it'll have a nice little flow to it rather than going all over the place. So pause the video and see what you get. So if you followed my advice, you divided by 2 and you got 108. And then you would divide by 2 again, leaving you with 54. And if you divided that by 2 again, you would be left with 27. And now you can't divide by 2 anymore. So you skip up to 3, and 27 divided by 3 is 9. And you should have finished with 3 3s and 3 2s at the bottom. Now remember, you must circle in groups of 2. So we have a pair of 2s and we have a pair of 3s. And then left over we have a single 2 and a single 3. And radical and 2s cannot hang out with 3s. I know it's sad, but that's just the way things are in math world. So this group of 2s can come outside of the radical, but that 2 must stay inside the radical. this 3 must stay inside the radical, and those 3's get to come outside. And then you simplify it by just multiplying. So 2 times 3 is 6, and 2 times 3 is also 6. So the square root of 216 will simplify to 6 root 6. Okay? For the next example, if you already have a number out front, you just leave them out front. So we all know that the square root of 25 is 5. So 2 times the square root of 25 is the exact same thing as saying 2 times 5, which is 10. And anything that works out to be a nice perfect number is easy to double check in your calculator. There are ways to double check to make sure you simplified correctly, but it's not perfect. You can talk to me about that later. Finally, 75 is not a perfect square root. So you would need to use the factor tree. The smallest thing you can divide by is 5. So you have 5 times 25. And then 25 splits up to 5 and 5. Circle your pair, box your single. 5 root 5 is what happens when you simplify the 75, but you cannot forget about the 3 that's already out front. So you have 15 root 5. Okay? So that right there is just how you simplify radicals. Our next step is how do you add and subtract them? Adding and subtracting radicals is like adding and subtracting variables. So, quick recap of something you already know. 2x plus 3x is 5x, because if you have 2 x's in your pocket and you put 3 more x's in your pocket, you now have 5 x's in your pocket. Okay? Then later on that day, you have 4 x's in your pocket and someone takes away 2 of them. You now have 2 x's left. But if you have 3 x's and 2 y's, you cannot add them together and all of a sudden have 5 z's. It does not work that way. So back in the day, you learned that this cannot be simplified, so you leave it alone. Well, in terms of radicals, it works out the exact same way. So if you have 2 root 3's and then you all of a sudden acquire 3 more root 3's, you actually have 5 root 3's. You do not have 5 root 6's. So when you are adding and subtracting, you must have the same radical to be able to combine. And when you combine them, you just add the number in front, your leading coefficient. So if you have 4 root 2's and you lose 2 root 2's, that leaves you with 2 root 2's. And finally, if you have 3 root 5's and you need to add 3 root 3's and you add 2 root 5's to it, since they are different radicals, you cannot simplify, so this is just done. That would be your final answer. Okay? So here's another one. Now, I'm calling this one a challenge, and because I will give you a hint, those two can be added together. And no, it's not because one has an 8 and the other one has a 1 and an 8. You need to think about this one. So pause the video if you think you can handle this dog on your own. The reason these can be added together is because they are not simplified. Another reason why simplifying is a crucial skill for radicals. Because 8, we've already done this before, but simplifies to 2 and 4 and then 2 and 2. So 8 simplifies to 2 root 2. But do not forget about the 2 that's already in front, so you have 4 root 2 plus. If we simplify the 18, you would have 2 and 9, and then 3 and 3. We can circle our 3's and box our 2, and that will simplify to 3 root 2. Don't forget about the 4. That's already in front. So 4 times 3 is 12 root 2's. So you have 4 root 2's plus 12 root 2's, which would give you 16 root 2's. So again, before you ever add or subtract or say something cannot be added or subtracted, make sure you are in simplified forms for your radicals. Okay? If you got that, high five. Next step is how do you multiply? So remember, when you multiply, it is okay to mix with different numbers. X times y, we would just say is xy. It's not that they cannot be multiplied. 2x times 3y would become 6xy because we're multiplying and we're not adding. So in this case, we could multiply the square root of 3 and the square root of 2 and just call that the square root of 6. Special note, always make sure you simplify when you're done. You cannot simplify the square root of 6. When you multiply and you have numbers on the outside, you multiply outside with outside and inside with inside. So 2 times 4 is 8, and the square root of 3 times the square root of 5 is the square root of 15. And you are done. Last example, in this row we have the square root of 2 times the square root of 6, which is going to give us the square root of 12. But this one, I will tell you, is not finished. And it's because you must always write your answer in simplified form. So this would give us 2 and 6, 2 and 3. So this pair of 2's comes together and we box the 3. That will end up giving us 2 root 3. Okay? So why don't you give the video a pause and see if you can do this next row, and we'll see how you do. So 4 times 3 is 12, and the square root of 2 times the square root of 8 is the square root of 16. We know the square root of 16 is 4, so this is like saying 12 times 4, which is 48 for the first example. If you got that right, good job. Second example, the square root of 2 square root of 12 times 3 square roots of 2 is going to give you 6 square roots of 24. Of course, you must break that down. 2 and 12, 2 and 6, 2 and 3. We have a group of 2's, but we have an individual 2 and an individual 3. So that will simplify to 2 root 6. But do not forget about the 6 that's already outside. So the final answer for this one would be 12 root 6. And again, if you got that, fantastic job. This last one is much easier than it appears because you can only multiply the 2 and the 3 because the 3 does not have a radical. So you just end up with 6 root 5's here. Okay? So that is multiplying with radicals. The last topic that we're going to discuss is division. And division is going to be the most complicated one. Not because it's more difficult to divide than it is to multiply. It's because division has certain rules we must abide by. And the rules are no radicals in the denominator. So before those situations come up, a lot of times it's just really easy to simplify. So for example, the square root of 12 divided by the square root of 3 is easy because we can easily divide 12 and 3. Just like multiplying, you can divide inside with inside and outside with outside. So the square root of 12 divided by the square root of 3 would give us the square root of 4, which we know is just straight up 2. And if anything is already a perfect square, you can just take it right off the bat. The square root of 9 we know is 3, and the square root of 4 we know is 2. So that example is already done. The square root of 8 cannot be simplified, but the square root of 9 is 3. So that one is actually pretty easy because it does not leave us with any radical in the denominator. But I hope you caught the fact that we are not done with that one. And it's because we cannot leave a square root of 8. We've done the square root of 8 a few times already in this video. By now you should know it's 2 root 2. So that would be your final answer. You must simplify radicals at all times. So this next row is going to get slightly more complicated because we have a square root of 3, or we have a 3 divided by a square root of 2. And you can't leave that answer because of the square root of 2 in the denominator. So what you need to do is get the denominator to have a perfect square by multiplying by a clever form of 1. What do I mean by that? Well, we know that 1 is a number. But 2 divided by 2 is also 1, and 10 divided by 10 is also 1, and 10,000 divided by 10,000 is also 1. So, if we want our denominator to be a perfect square, we need to multiply the top and bottom by that clever form of 1 using the denominator. The square root of 2 divided by the square root of 2 is 1. But if you multiply it to the top, you would end up with 3 root 2 over the square root of 4. And we know that the square root of 4 is 2. So as you can see, we got rid of the denominator, and we now have a simplified expression using radicals. So this guy right here, you have to get rid of that same 2 by multiplying the top and bottom. And we have 4 times the square root of 2, which cannot be combined because they're outside and inside. And the square root of 2 times the square root of 4, or 2, is the square root of 4. The square root of 4 is 2, so you end up with 4 root 2 over 2. But now we go back to dividing, where outsides can be simplified. 4 divided by 2 can just simplify to 2 root 2. Okay? So why don't you pause the video and try the last one. Click play when you're ready again. You have to multiply the top and bottom by the square root of 2. Now, square root of 3 times the square root of 2 is the square root of 6 over the square root of 2 times the square root of 2 is 4, which we know square root of 4 is 2. Now this you cannot simplify any further because this is inside of a radical and the 2 is not. So that one is done. Now here's the challenge of the day. Reason why this is a challenge is because this one's going to take a few steps. So why don't you go ahead and give this one a try. Click play when you're ready and we are done. First thing you would do is multiply the top and bottom by the square root of 6. That will give you 3 square roots of 48 on top over the square root of 36 in the denominator, which we know is 3 root 48 over 6. Now, we can simplify this now. We can call that the square root of 48 over 2. But we're not done because the square root of 48 can be simplified. So 48 can be simplified to 2 and 24, 2 and 12, 2 and 6, 2 and 3. We have 1 pair of 2's, 2 pair of 2's. So outside we can have a 2, another 2. We box our 3 and we have the square root of 3. All over 2 still. So that's 4 root 3 over 2, and of course 4 divided by 2 is 2, so that all simplifies to 2 root 3. Alright, I know this video was a little long, but being able to work with radicals is a very essential skill, so I hope you stuck with it the whole time. This is Longo and I'm out. See you, bye.